Right. Hi, folks. Really good to have you at our March webinar. Last month, we started our February webinar talking about cooler and wetter conditions that week. Now, this week, we're dealing with record-breaking heat. While this back and forth in the atmosphere is not unusual in March, the temperatures that the West and the Southwest are experiencing are definitely above average. So yesterday, March 18th, the Phoenix Weather Station broke their earliest 100-degree temperature on record. The previous record was set on March 26, 1988. But then yesterday's temp didn't just stop at 100 degrees. The temperature at the Phoenix station ended with 102 degrees, which was the first time ever 102 was measured in March at the Phoenix station. So Phoenix is expecting even hotter temperatures today and through Sunday. So let's mention some record dates. The earliest the Phoenix station measured 104 degrees happened April 7th, 1989. And then the earliest that Phoenix reached 105 degrees, that happened April 29th, 1992. Those temperatures are definitely possible today and tomorrow. Just an FYI that Palm Springs is forecasted to hit 108 today. They hit 106 degrees yesterday. We want everyone to be safe. Spring training has moved their games to the evening. Remember to take care of yourself, your neighbors, and your pets. So at last month's webinar, we did talk about hotter winter temperatures, and now it's official. Arizona and several other West and Southwest states experienced their hottest winter on record. The meteorological winter runs December through February. So if you look at the map that shows the average mean temperature rankings, you can see that a lot of weather stations ranked with their hottest winter on record. And then every Arizona county had their hottest winter on record. So now looking just at February for Arizona, the state had its hottest February on record. Those records, just a reminder, they go all the way back to 1895. Several counties had their hottest February on record. So those counties were Apache, Graham, Maricopa, Pima, Pinal, Santa Cruz counties. They all had their hottest February on record. Most other counties had their second hottest or tied with their second hottest February on record. Then zooming into cities, Phoenix and Tucson had their hottest February on record. Flagstaff had their fifth hottest February on record. So now let's take a look at that precipitation. We had a low pressure system in mid-February, and that brought close to average amounts of rain and mountain snow in northern Arizona. But then central and southern Arizona only received below average precipitation. At the end of the month, every county had below average precipitation for February. So now let's take a look at what goes on with, if we can get it, we're going to try and get this. There we go. So let's take a look at the last 12 months. The last 12 months ranked as the hottest March to February on record for Arizona. The only counties that didn't rank with their hottest March to February on record, that was La Paz, Yuma, Maricopa, Gila, Greenlee, and Cochise counties. And they ranked not as the hottest like the other counties, but as their second hottest March to February on record. Now, with precipitation, fortunately, 5 of the last 12 months were wetter than average for the state. So the wetter months were May and June, and then, of course, September, October, November. The counties, Yavapai and Yuma County, they both had above average amounts of precipitation for the last 12 months. But then let's take a look here for the water year. For the state, the water year is still above average. It has 5.2 inches of precipitation. That number comes from statewide precipitation from October 2025 to February 2026. We know we had a wet fall last year. Let's just look at the last 3 months. So just the winter precipitation from December to February for the state. This past winter was the 35th driest winter on record for the state. The only county that had above average winter precipitation was Cochise County. Zooming into Maricopa County, they had their 14th driest winter on record. And so then we'll talk about this, which is snow drought. Snow drought means that these locations, and in particular Arizona, much of the West, has had below average amounts of snow this winter. The Snowslide Canyon station at Mount Humphreys is the only station in Arizona that's still showing a good amount of snowpack. In the previous couple of winters, Arizona received more snowpack in March and April than in December and January. Is it possible that Arizona gets maybe some more snowpack this April? Sure, it's possible, but if it does happen, it won't be a significant amount of snow. So now let's take a look at short-term drought. A year ago, so March 2025, short-term drought had advanced. And that happened because of the dry monsoon in 2024, and then the second driest winter for the state, that was winter 2025. So then the wet fall from last year really helped improve short-term drought. But now you can see how the dry winter this year, 2026, has started to again advance short-term drought. Arizona uses SPEI blends for their long-term drought maps. SPEI stands for Standardized Precipitation and Evapotranspiration Index, meaning it takes into account hotter temperatures because hotter temperatures make a thirstier atmosphere. You can see the last 60 months, so that's March 2021 to February 2026, adding all those records together and comparing to other years, Arizona has been dry and very hot over the last 60 months. Then I bet we all want to start thinking about the monsoon. So I pulled the CPC outlook for June, July, August, and it's showing an above average precipitation outlook for Arizona and New Mexico. The summer outlooks have actually been showing a wetter summer for the last month or so. The rationale for a wetter monsoon comes from having drier soils and below average snowpacks in winter. So what that can do, it can help with an early start to the monsoonal atmospheric flow. But if you remember, we had a somewhat similar outlook for last year's monsoon. So we'll all keep watching this as we get closer and closer. I did want to talk about this. CPC has put a 62% chance that El Nino will emerge this fall. Arizona has a better statistical relationship between El Nino and winter precipitation. So this will be an interesting watch as well. We always appreciate making sure Arizona has the latest information about our weather, water, and climate. And you can get more details on our website. So that's azclimate.asu.edu. I'm going to stop share and we're going to bring in our guest speaker. We're thrilled to have Dr. Bo Svoma, Principal Climate Scientist, Meteorologist for SRP. Really interesting topic that we're going to hear about. Thanks for talking to us today, Bo. You're ready to go whenever you are.
Excellent. Thank you, Erin. And right now you should see my title slide. And then I just
Absolutely.
want to make sure you can see it advance before I get
Looks
going.
looks great. You're ready to go.
All right. So I am going to talk about the snowpack this winter, particularly on the Black River, which is a part of the Salt River watershed, and some airborne LiDAR measurements that were taken there from a company that's called Airborne Snow Observatories. It used to be a NASA company, but it's spun off into a private company or since then. Okay, so to start off with some acknowledgments, this project's funded by the U.S. Bureau of Reclamation and also Arizona State University and also Salt River Project. Most of the funding coming from the U.S. Bureau of Reclamation as part of their snow water supply forecasting program. You see some researchers there that I'm acknowledging as part of ASU's research team, and also pointing out that Airborne Snow Observatories is the company that was hired to fly LiDAR over this key part of Arizona. All right, so I'm going to talk about Salt and Verde River and SRP, Salt River Project overview before we get going, just so we're all on the same page. And then I'll talk about the wet fall we had and the dry winter as it pertains to this project, which involved LiDAR measurements of the snowpack on the Black River. And all that's really aimed at improving hydrologic modeling for forecasting stream flow into reservoirs like Roosevelt Lake. So the Salt River Project is one of the earliest and most successful federal reclamation projects. It started in the early 20th century with the construction of Roosevelt Dam being completed in 1911. And the Salt and the Verde Rivers are the single largest water supply to the Phoenix metropolitan area, with Colorado River water and groundwater a very close second and third. It's almost a three-way tie in the long term. So a very important water supply are the Salt and the Verde Rivers and the reservoirs on the rivers. The Salt River watershed extends off to New Mexico. The Verde River watershed extends um, north of the Phoenix metropolitan area, almost off to as far north as the Grand Canyon. The area circled there, it might look like a small part of the watershed, but the stream flow that fills up reservoirs like Roosevelt Lake and Horseshoe and Bartlett Lakes, which are much closer to the Phoenix metropolitan area in the lower left-hand part of this map, the stream flow is generated from relatively small portions of the watershed, the high elevation ponderosa pine and mixed conifer forests, and the upper Black River Basin is a very important part of the watershed for generating stream flow that can fill up Roosevelt Lake during wet winters. That is also an area that typically develops a stable snowpack in the winter, which is why we're interested in monitoring the snow in a new way there to inform hydrologic modeling for ultimately, which will hopefully someday be operational forecasting of stream flow to guide reservoir operations as part of Phoenix's water supply. Okay, so this is the watershed you just saw. This is aerial average precipitation. For the dash line is last water year, fall, winter, and spring in particular. The red line is normal, and the solid line is this water year. And we actually on the Salt and Verde River watershed had the wettest October, November since 1978. And this project that I'm talking about actually started last year, and we had really dry weather last year, no snow, so we didn't even have airborne snow observatories fly. So this year, the wet fall was a really exciting start. It didn't really put a lot of snowpack on the Salt River watershed because the storms were too warm, but it really got the soils moist and the rivers were flowing already, and it definitely was the right track for productive uh, runoff season, which is good for water supplies and, of course, for the research that we're doing. After that wet period in November, weather models looked like this for the very beginning of December, which was really exciting because this is cold pattern. And I was thinking, oh my goodness, after this really wet fall, we're going to lay down an early snowpack and be ready to rock with this project with airborne snow observatories and ASU. I was always suspicious of this, even though a lot of the weather model runs were suggesting wet weather. This is a weather pattern where ultimately Arizona can easily get missed by storms to the northeast. So it was too good to be true. And even though this forecast here was only 156 hours out, pretty quickly after this, all the weather models went dry. And we started off very dry in December and basically have never gotten a major storm on the watershed since then. There were a couple of winter storm warnings in the Flagstaff area in February, but ultimately those weren't excellent by any means in terms of total water put down on the watershed. So you could see after the wet fall, a very dry winter, actually as dry as last winter, as you can see with that dash line compared to the solid line. But the snow did fall starting in January and then some more in February and then a little bit in March. Ultimately, a stable snowpack never developed on the Salt River watershed like it normally does. It came and went because it never got very deep and it was pretty darn hot, as Aaron mentioned. But the snow came at just the right times to where we could coordinate SRP helicopter snow surveys with flights from airborne snow observatories. And what that is actually is, like I said, this airborne snow observatories used to be a NASA project flying over primarily the Sierra Nevadas in California to improve stream flow forecasting there from snow monitoring to improve snow melt forecasting. But also they've been doing it over the Colorado River Basin recently, but now it's a private company. And to my knowledge, these are the first flights in Arizona ever. And what this does is this plane that you see here flies over a pretty large area of Arizona for LiDAR measurements like this at this resolution. I believe it's like 3 meter resolution. You'll see the map later on. So the plane flies over the Black River Basin in Arizona. There's a LiDAR among other instrumentation on the bottom of the plane. The LiDAR shoots light toward the ground, and then that light bounces back up toward the sensor. The travel time gives an idea of the snow depth with a snow off flight that guides that, giving the last piece of the puzzle that was taken last fall. So you subtract the LiDAR return depth measurements from snow on from the snow off flight, and you get depth basically. So the plane gets depth at high resolution over a large area. But then also SRP, along with some ASU researchers, flew in the helicopter and landed in key spots and measured snow density because snow density can't be measured by the LiDAR flight, just snow depth. So there's a model behind the scenes that ASO runs called iSnowball that has density in it, and having density measurements allows bias corrections of that model to improve um, the estimates of snow water equivalent, the amount of actual liquid water equivalent of the snowpack that's out there on the watershed ready to melt and come down, fill up the reservoirs. So the snow was so shallow, we had to use a unique technique to measure this snow. It's called a snowboard sampler, where we basically have to get down in there with a spatula on our hands and knees and measure it with a really precise scale to the nearest tenth of a centimeter, I believe, in terms of, I guess, a millimeter in terms of snow water equivalent and depth. Otherwise, we'd be doing it with what's called a federal sampler, which is what you typically do when there's deeper snow. But when the snow was this shallow, we had to do it with more precise measurements. So the snow density measurements we collected definitely helped in the snow water equivalent maps that airborne snow observatories produced. So that was fun. And here's some results from the February 23rd snow survey. There were 3 flights from airborne snow observatories, one in January, one in February, and one in March. On the left here, you see the map from the February 23rd results. Basically, this is a very, very weak snowpack. You see that the very highest elevations by Mount Baldy, the snow water equivalent is nearly 6 inches, and most of the basin is well below 3 inches snow water equivalent, but a lot of snow free area. Typically in late February, you'd want to see a lot more widespread 3 inch plus snow water equivalent. So this is a very, very minor snowpack, but there is a silver lining that I'll talk about on the next slide, and it's because of the wet fall. But before I get to the next slide, check out the graphics on the right showing some of the cool information that these 3 meter resolution snow depth measuring can produce. You could see that there's this graphic here that shows the aspect of the slopes, the terrain. So north aspect slopes that don't receive a lot of sunlight, and south aspect slopes that receive a lot of direct sunlight. And the closer you get to the center of this circle, you get higher in elevation. So the cool thing you see here from the March 12th survey is that there's some surprisingly deep snow on the high elevation northeast aspects, above 6 inches of snow water equivalent. But pretty much everywhere else in lower elevations and other aspects, you could see lost a lot of snowpack from the February snow survey to the March snow survey, the March flight. And only the only blue colors in the lower right hand graphic there are those high elevation north and northeast aspects, showing that the snow was able to hold on there during that generally hot and dry period between those two snow surveys, but it melted everywhere else. So that's definitely some interesting high resolution information of the snowpack that airborne snow observatories can produce. Like I said, it was a very minor snowpack that would normally be hydrologically insignificant, and you really couldn't get any type of modeling value out of it. But I think this year we can. So this is how the Black River streamflow responded to the snowmelt, the pathetic snowmelt that there was this year. You could see that there was actually a response in the Black River from the snow melting in late February and early March. And again, this is a melting of a very, very minor snowpack, one of the smallest snowpacks on record. In 2021, there was a minor snowpack, but certainly bigger than this year. But we didn't have the wet fall, so you could see that comparing the Black River in 2021 to this year, the wet fall is the game changer, where the minor snowmelt water inputs actually produced a stream flow signal in the Black River, and it's because the soils were so moist. There had been pulses of water through the creeks and streams earlier in the year to kind of pave the way for that snowmelt actually making it to the Black River and ultimately to Roosevelt Lake. Still a very minor runoff from this. In a wet winter, you'd see values that are 5 to 10 times more than this and sustained for a long time. But it's interesting that if you're thinking about improving hydrologic models, if you want to be able to determine if you can capture the power of a wet fall really well in a hydrologic model, perhaps this extreme winter was a good case study for that. So in summary, wet falls, what wet fall we had, but a dry winter resulted in a historically small snowpack. The hot weather didn't help either because every time snow fell, even at 9,000 feet elevation, any sunlight plus the warmer temperatures melted out the snow and all but the highly sheltered areas. Um, and then we had 3 airborne snow observatory flights flying LiDAR, and those measurements coupled with on-ground measurements produced very high resolution maps of snow water equivalent that can inform hydrologic modeling. That's what the research project is about between ASU and SRP that the USBR is funding. And even though we had very small snowpack this year, I think it's interesting that the wet fall aided in the minimal snowmelt actually producing a streamflow response in the Black River, which is something that you'd probably want to be able to model. If you can model that extreme year, then maybe modeling average years, you might be more accurate there. So I think there was a benefit, even though we had a dry winter and a minor snowpack. So that's all I have. Um, Thanks for listening, everybody. Rumor has it that typically there's not questions in this forum, so I'm okay with just saying thank you for listening and calling it quits here. Thanks, everybody.
Thanks. Thanks. I appreciate that. I am going to stop recording. I'm glad everyone could come, and that was great. That was a great talk.